Okay, now let's talk about the variation of parameters method. Here we solve the non-homogeneous y double prime px y prime qxy equal to some forcing f. So you already saw this in math 187. So I'm just gonna review what you did. Okay. Right. So we have the following answers, meaning a guessed solution. If y1 and y2 are the solutions for the case f equal to 0, then the general solution to start is of the following form: c1y1 c2y2 plus u1t y1t u2t y2t. And we will identify these two functions the same way we did in reduction of order. You might ask, why is this a natural form? Why multiplied by u1? And so this is not tested, but the intuition is f of t. Why do everything x? F of x is equal to the integral of f of y delta x minus y dy, where delta is the Dirac delta. So if you like, one intuition, if you are curious, is solving star is the same as solving Ly equal to delta x minus y due to linearity. Okay. If you have more questions, just tell me, and we can go over it in detail if you're interested. All right. So now I'll just review what you did in 187. So we want to find U1 and U2, okay? So call this Y non-homogeneous part. Then we have the following. So Y non-homogeneous, double prime, px prime qx. Now if you use that y1, y2 are homogeneous. Homogeneous solutions. you get the following. So you get d dx. So you get two zeros. I'm not going to go into it. And then you get the following. That's one term. Then you have the same function without derivative. And you're left with the following: y1, u1. And remember, we asked this to be non-homogeneous. So I might as well write it here. So this is equal to f of x. Let me put, so this is equal to f of x. Okay. All right. We have two unknowns. So we have two known parts. These are known. And these are unknown. Right? But we only have one equation. So you need two equations for two unknowns, right? From linear algebra. So that means that one of them, we need to create one more equation. But thankfully, we see that we have the same function here. Call it g of x. G of x. So if g of x is 0, then its derivative is also 0. So both of these terms disappear. So we get the following system: y1 prime, y1 u1 prime, y2 u2 prime, 0. That's dot g. And then what's left here? So y1 prime, u1 prime, y2 prime, u2 prime equal to f of x. Okay. All right. This is a system. So we have a matrix times the two unknowns equal to a 0 f of x. Okay. So this is of the form A, let me write it u equal to b, right? Now, if A is not invertible, you can still solve the system even if A is not invertible. We can still solve it with Cramer's rule, right? So you did this last year in 187. Okay. Right. So that means the u1 prime is equal to the determinant of A, and then determinant of A, where you replace the first column, but by what's on the right-hand side. Okay. So if you do that, you get minus y2 f of x, and this is just the Wronskian, right? So let's go up. That's the these are homogeneous solutions, right? And so the determinant of that matrix was just the Wronskian from 3.1, section 3.1. So this is the Wronskian of y1, y2. Okay. All right, and then u2 prime is equal to same thing, but then we swap the second column by B. So that gives you a y1 f of x. Okay. Right, so we're almost done. So then y non-homogeneous is equal to y1 x times the integral of y2, let's say t, f of t with a minus dt, and y2x y1t f of t, and then the Wronski dt. All right, so that's the non-homogeneous part, and that's all for the method. Next, we